In this lesson, we're going to cover the side-splitting theorem. So we have a triangle ABC. This could be any type of triangle, isosceles, right triangle, scalene. Doesn't really matter what type of triangle it is. The side-splitting theorem is going to work for it. The side-splitting theorem states that if we were to draw any line, so long as it's inside the triangle and it's parallel to another side, so in this case we're going to draw one parallel to AC, and we'll give this line segment a name. We'll call it XY. Okay, before I go any further, I just want to point out that X and Y do not have to be midpoints. It's possible that they could be midpoints. It'll still hold true, but they don't have to be. So I deliberately made it so that BX is significantly bigger than AX. We can see that X is not the midpoint here and Y is not the midpoint of BC. Okay, but XY is drawn, so it is parallel to AC. Okay, so let's look at this. If these two lines are parallel, I'm just going to extend it a bit and say that we have line XY such as this, and line AC such as this. Okay, then we have this line at BXA, which I'll just continue. And we could see our pair of parallel lines and the transversal. From this, we'll see that this angle, angle A, is congruent to angle BXY. These are corresponding angles. So now let's take this back into our triangle without these lines. So we have these two angles are congruent. Okay, we can do the same thing on the other side. We'll continue XY through. And we'll continue AC through. If we were to continue line segment BYC to make it into a line like such, again we'll have our parallel lines and a transversal. We see that angle C is congruent to angle BYX, again because they're corresponding. So it's, again, take a look at this back on our triangle. So we end up with these two angles are congruent. Now also notice when we have our triangle XBY and triangle ABC, that this angle B is in both of them. So of course this angle is going to be the same in both triangles because it's the same exact angle in both triangles. So we have that all the angles in the triangles are the same. And that means that these two triangles are proportionate to each other. So when I sum up proportion, I'm just going to write down big triangle over small triangle. So in other words, if I compare a line segment in one triangle, I'm going to compare it to the same line segment in the smaller one if I'm doing the bigger one. So for example, in the big triangle, we have line segment AB. That's the side of the big triangle. Okay, and that corresponds to the side XB in the smaller triangle. Okay, also in the big triangle is this base, AC. That corresponds to this side XY in the small triangle. And then last we have side BC in the big triangle, and that corresponds to BY in the smaller triangle. So from this we can make a whole number of proportions. For example, we could just take any two, such as these two, and make a proportion we could solve, such as AB over XB equals AC over XY. We could also select these two. So we have AC over XY equals BC over BY. And we could take also the first and the last together. So we end up with AB over XB equals BC over BY.